Welcome to this lesson on common code in Kotlin Multiplatform. In this video, you'll learn how to write platform-independent Kotlin code that can be shared across multiple platforms. This is one of the most powerful features of Kotlin Multiplatform, allowing you to write your business logic once and use it on Android, iOS, and other platforms. By the end of this lesson, you'll understand how to maximize code reuse and reduce duplication in your multi-platform projects. Common code refers to Kotlin code that is written in the commonMain source set and runs on all target platforms without any modification. This includes your business logic, data models, and utility functions. It also encompasses network requests and API clients, allowing you to handle data fetching in one place. Additionally, you can implement data validation and algorithms in common code, ensuring consistent behavior across all platforms. The key benefit is that you write this code once, and it works everywhere. A Kotlin multi-platform project is organized into three main source sets. First, we have commonMain, which contains shared code that works on all platforms. This is where most of your application logic should live. Next, we have Android main, which contains Android-specific implementations for features that require platform-specific APIs. Finally, we have iOS main, which contains iOS-specific implementations. This structure allows you to keep your shared code separate from platform-specific code, making your project more maintainable and organized. Let's look at a simple example of common code. Here we have a data class called user with three properties: id, name, and email. This data class can be used on both Android and iOS without any changes. Below that, we have a function called isValidEmail that takes an email string and returns a Boolean. It checks if the email contains an @ symbol and a dot. This validation logic works identically on all platforms. Notice how this code uses only standard Kotlin features without any platform-specific APIs, making it perfectly suitable for commonMain. Sometimes you need to access platform-specific APIs while keeping a common interface in your shared code. This is where the expect actual mechanism comes in. The expect keyword is used to declare an interface or function signature in commonMain. This declaration tells the compiler that this functionality will be provided by each platform. The actual keyword is used to implement that declaration in each platform-specific source set. This mechanism allows you to write code in commonMain that calls platform-specific implementations without knowing the details of how each platform works. In commonMain, you declare your expected classes and functions. Here we have an expect class called platform with a property called name. Below that, we have an expect function called getPlatformInfo that returns a string. Notice that these declarations have no implementation. They simply define the interface that each platform must provide. The compiler will ensure that every platform provides an actual implementation for these declarations. This allows you to use platform and getPlatformInfo throughout your common code, even though their implementations are platform-specific. Now let's see how each platform implements the expected declarations. In Android main, we create an actual class platform where the name property is set to Android. The actual function getPlatformInfo returns a string that includes the Android SDK version using build.version.sdk_int. In iOS main, we also create an actual class platform, but this time the name is set to iOS. The actual function getPlatformInfo returns a string with the iOS system version using UI_device.system version. Each platform provides its own implementation using platform-specific APIs, but they can both be called from common code. Let's wrap up with some best practices for working with common code. First, always maximize the amount of code in commonMain. The more code you can share, the less duplication you'll have, and the easier maintenance becomes. Second, use expect actual only when truly necessary. Reserve it for cases where you absolutely need platform-specific APIs. Third, prefer multi-platform libraries over platform APIs whenever possible. Libraries like Ktor for networking and SQLite for databases work across all platforms and eliminate the need for expect actual declarations. Finally, keep your platform implementations simple and focused. They should be thin wrappers around platform APIs, with most of your logic residing in common code.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.